Hello everyone, in this presentation I'm going to talk about what the Gaussian distribution is, where it came from, and how it appears everywhere. The Gaussian distribution, also known as the normal distribution, has a bell curve shape when plotted on a graph. The graph shows the symmetry of the distribution. Because of its symmetry, the distribution follows a 68, 95, 99.7 rule, which states that 68% of the distribution falls within one standard deviation, 95% falls within two standard deviations, 99.7 falls within three standard deviations. Now, what is a standard deviation and the equation above the graph, you may ask? The standard deviation measures how spread out the data is from the mean, and in this equation it is represented as the sigma symbol and is squared. And the sigma squared is also known as the variance. The mean or the average is in the center of the distribution and is represented as the mu in the equation. E is a constant approximately 2.72 and pi is a constant approximately 3.15. This function is used for many things in the world today, but where did it come from? In 1733, Abraham de Moivre discovered an early form of the normal distribution from the binomial distribution. He found that as the number of trials in a binomial distribution increases, the distribution, if plotted, will show a bell-curved shape. This started the idea of the central limit theorem. In 1778, Pierre-Simon Laplace works and formalizes the central limit theorem, which proves that the sum of many independent random variables leads to a normal distribution. In 1803, Gaussian independently developed the normal distribution and derived its mathematical formula, which features the exponential function and describes the bell curve shape. Gaussian uses the distribution in both theory and practical applications, particularly in astronomy and error theory. Now, in everyday life, in signal processing, many communication systems and sensors model the noise as Gaussian because noise consists of many small independent noises and if summed up will result in a normal distribution, proving the central limit theorem. This helps engineers design effective filters that could make the signal clearer. In control systems, the Gaussian distribution supports the Kalman filter, which makes predictions in a system and updates the system based off those predictions to reduce uncertainty. In machine learning, some machines learn algorithms like linear regression and assume that the data follows a normal distribution. The models, like the Gaussian mixture models, use the Gaussian distribution to find patterns in the data. In financial modeling, they use models and assume that returns on investments follow a normal distribution, which means that most returns are close to an average and make extreme losses or gains rare. In customer behavior, businesses use the Gaussian distribution to group customers into segments based on their behaviors compared to the average. These behaviors follow a bell curve and help businesses target their marketing efforts and set expectations for average sales. In quality control and manufacturing, manufacturers analyze data with the bell curve to see when processes are starting to drift and need adjustments. This helps them keep production consistent and reliable. In psychological testing, the Gaussian distribution is used to understand how scores or traits are distributed across a population to show that most people have an average score and fewer people have very low or high scores. In sociology, Gaussian distribution is applied in income distributions to analyze wealth and inequality. It is also applied in voting patterns to study how common behaviors are distributed, and also applied in health studies to understand the average health. In research, data collected from experiments and surveys tends to follow a bell curve, which helps identify patterns and to determine if the data is consistent or are any or if there are any statistically significant differences. Now, after we saw how common the normal distribution is, you may be wondering, why is that? Well, it is all because of the central limit theorem. This idea tells us that the sum of many independent things tend to create a normal distribution, no matter what those individual things are. Thank you for watching, and I hope you understand more about the Gaussian distribution.